Saudi Arabia has long been a powerhouse in the oil industry, but a recent announcement has shocked the entire industry and raised eyebrows worldwide. So what is this surprising news, and what implications could it have for the global economy and energy markets? Watch this video till the end to find out. Here we begin. Saudi Arabia is a desert country with stable weather conditions and distinct differences between coastal and interior regions. The Rub al Khali Desert is the world's largest continuous sand area, covering southeastern Saudi Arabia, parts of Yemen, Oman, and the United Arab Emirates. The desert is virtually uninhabited but has large petroleum reserves, including Al Ghawar, the world's largest conventional oil field. In addition, Al Shaba, located in the southeast, has significant natural gas reserves and refinery operations. Despite its harsh conditions, the Rub al Khali is a valuable energy source crucial to the global economy. Problem: despite its vast oil reserves, Saudi Arabia faces a significant challenge in securing its food supply, with over 80% of its food imported using oil profits. To address this issue, the Saudi government has focused on improving its agricultural sector as part of its Vision 2030 program. In the past, the government attempted agricultural self-sufficiency with aggressive subsidies for farmers in the 1980s. Due to poor techniques and mismanagement of water resources, these efforts were reimagined in 2007. Today, the kingdom promotes sustainable agriculture by subsidizing livestock farmers' manufactured feed and encouraging vegetable growth through greenhouses and drip irrigation methods to save water. The agricultural sector is a significant source of employment in Saudi Arabia. In addition, the government aims to develop rural areas and improve the use of limited natural resources while combating hunger and poverty. Recent technological developments, such as satellite imagery of farmland, have enabled researchers to understand the relationship between crop growth and water use. This allows farmers to estimate which crop will yield the most given a certain amount of water. Additionally, liquid nanoclay, a new technology that coats sand with clay, has shown promise in reducing water consumption by over 50% in its trial run in Emirati farms. While expensive, LNC offers hope for farming in water-stressed regions like Saudi Arabia. The current surprising phenomenon, the desalination project, the solution. The Ras Al Khair desalination plant of Saline Water Conversion Corporation has been creating waves in the industry as a revolutionary solution to the problem of water scarcity. This hybrid plant employs both multi-stage flashing and reverse osmosis technologies, making it the world's largest desalination plant with a daily capacity of 228 million imperial gallons, or 728 million liters, capable of serving approximately 3.5 billion people in Riyadh. The construction of this phenomenal plant began in early 2011 and was completed in April 2014, with a staggering cost of SAR 27 billion, approximately $2 billion. Doosan and its consortium partner, Saudi Archaeology, were the primary contractors for the plant's construction, with Poirier as the project's consultant. The engineering, procurement, and construction contracts included equipment, facility production, installation, testing, and commissioning. The desalination plant comprises 8 MSF units and 17 row units. The MSF units can produce 160 MGD, while the row units can produce 68. Construction of a row building, switchgear buildings, a wastewater treatment plant, a chemical dosing building, and the installation of a dissolved air flotation unit and 2 dual media filters were all part of the Ras Al Khair desalination plant project. In addition, ground improvement and backfill work were completed on the row and MSF plant sites. The plant's offshore elements included installing 3 kilometers of GRP discharge pipes with end diffusers, and constructing an intake channel consisting of a dredge channel 2, 1.4-kilometer rock breakwaters, a seawater intake pump house, and a discharge chamber to the pipes. This plant's hybrid treatment of MSF and row processes sets it apart from other desalination plants. The MSF desalination process involves heating seawater to generate steam and then condensing the steam to produce desalinated water. The process begins with the brine heater, heating the seawater to a high temperature. Next, the heated seawater is transferred to an evaporator, where the pressure is lower, allowing the water to boil quickly and flash into steam. The remaining water then goes through a series of additional stages, each with a lower pressure than the previous one. Condensing the vapors from the heat exchanger tubings that run through each stage converts the flashing vapor into fresh water. Finally, the combined cycle power plant's waste heat will heat the tubes within the distiller unit's brine heaters. On the other hand, the row process uses pressure to force seawater through a semi-permeable membrane to remove sodium and chloride. The process begins with pre-treatment using any of these methods, including coagulation, flocculation, sedimentation, and filtration, as well as microfiltration and ultrafiltration. The second stage entails supplying pressure via pumps to force water through the membrane. A pressure vessel and a membrane comprise the membrane assembly. The final post-treatment stage employs energy recovery devices such as turbochargers. It entails removing gases such as hydrogen sulfide from the water, measuring its acidity and alkalinity, and preparing it for distribution. The project's second phase will see the construction of a 650 megawatt combined cycle power plant consisting of 5 600 megawatt combined cycle gas turbine blocks and 2 220 megawatt single cycle gas turbine units. In addition, the project's alumina refinery will consume up to 350 megawatts of electricity and 25,000 cube meters of water per day. Comment below and subscribe for more.